All right, 14.3, verifying trig identities. A trig identity is a statement using trigonometric functions that we know is true, okay? Now, we are going to be told a trig identity, and I hate to use this word because I know that it makes all of you shudder, but we are going to be proving that it works. Now, don't worry, there's no two columns, there's no statements, reasons, craziness like you had in geometry. But we are going to be verifying trig identities. We are going to be verifying that certain statements work. All right, before we get started with that, we're going to take a look at an example. We're given that the tangent of theta is 5/12, and we know that the angle theta is between pi and 3 pi over 2. Okay, it says x, but it's really supposed to be angle theta. Is between pi and 3 pi over 2. Find the values of the other trig functions. Now I know we could do this old school the way we did in chapter 13. We could draw it in the third quadrant. We could figure out what the sine is, what the cosine is, find all their buddies. All right, what I'm looking at today is looking at a different way of doing these using our trig identities. Okay, by trig identities, you need to look at your sheet. All right, your trig identities on this sheet look like this. Looking under the big 8. These are the big 8. These are going to be your best friend for the next several days when you're doing these. Notice there are a lot of statements on here that are extremely important. First of all, we've already been told that tangent is sine over cosine. Now, we know cotangent is a reciprocal. So cotangent is cosine over sine. Cotangent is the reciprocal of tangent. So cotangent is 1 over tangent. Cosecant is the reciprocal of sine. It's 1 over sine. Secant buddies with cosine, so it's 1 over cosine. All right, some new ones you have not seen before. And 6, 7, and 8, they look big and scary, but they're really rewritten parts of it. Sine squared plus cosine squared is always equal to 1. Sine squared plus cosine squared is always equal to 1. Now, if I subtract cosine squared from its both sides, that means sine squared is 1 minus cosine squared. If I were to subtract sine squared from both sides, that means cosine squared is really equal to 1 minus sine squared. So really, these two are just building off of that one. All right, next one. 1 plus tangent squared is secant squared. 1 plus tangent squared is secant squared. So if I subtract 1 from both sides, that means tangent squared is secant squared minus 1. If I subtract tangent squared from both sides, that means secant squared subtract tangent squared is equal to 1. All right. 8th one. 1 plus cotangent squared is cosecant squared. 1 plus cotangent squared is cosecant squared. Well, if I subtract 1 from both sides, that means cotangent squared is cosecant squared minus 1. If I subtract cotangent squared from both sides, that means cosecant squared subtract cotangent squared is really equal to 1. So once again, the two bottom ones in each piece are really rewriting of the first one. Okay? You want this list close and near when you are working on these types of problems. So, for example, if we take a look at that first one, we know the tangent. Well, on my big 8, which ones involve tangent? 7. Okay, yep, 1, tangent is sine over cosine, and then 7. Well, 7 says that 1 plus tangent squared is equal to secant squared. Okay, so if I go back over here, that means 1 plus tangent squared of theta has to be equal to secant squared of theta. Well, I know tangent of theta. So that's going to be 1 plus tangent of theta is 5/12 squared is equal to secant squared. Is everybody okay with me so far? All right, so 1 plus, well, 5/12 squared, 5/12 times 5/12 is going to be 25 over 144 equals secant squared. All right, any thoughts now? Really trying to get to secant. You bet. If I'm going to add 1 and 25 over 144, well, 1 is 144 over 144. So that's going to be 169 over 144 is equal to secant squared. All right, now what? Because how do I get 13 over 12? I'm going to take the square root on both sides. So secant of theta is equal to 13 over 12. Is that true? I think we missed something. What do I have to remember when I take the square root on both sides? Plus or minus. Okay, now, we really need to think here though. We really need to think here though, because I need to think about something with cast. I know that the tangent is 5/12, and I know that that tangent is found between pi and 3 pi over 2. Where is that? Third quadrant, okay? Third quadrant is a T. Should tangent be positive? You bet. What does that mean about secant? It better be negative. So I don't want plus or minus 13/12. I want the secant of theta to be negative 13/12. Okay, so I start out, secant of theta is negative 13/12. Now, the minute that I know that the secant of theta is negative 13/12, what do I also know? Cosine. How much is cosine? Negative 12 over 13. All right. Now, we also learned another trig identity, or we're going to use a trig identity from before. We know that tangent is sine over cosine, correct? Tangent is sine over cosine. Well, the tangent is 5/12 equal to the sine over a cosine, which is negative 12/13. What am I going to do to solve for sine? What am I going to do? Do we have any suggestions on what I could do to solve for sine? I could cross multiply, or just a question. What's happening to my sine? It's being divided by negative 12/13. So what am I going to do to get sine by itself? Multiply both sides by negative 12/13. So the sine of theta is equal to, my 12s are going to cancel, negative 5/13. Okay, sine is negative 5/13. Which other one do I know then? Who's buddies with sine? Cosecant, all right. What is cosecant going to be? Negative 13/5. Okay, so I got sine at negative 5/13, cosecant negative 13/5, cosine negative 12/13, secant negative 13/12, tangent is 5/12. I have 5 of them right now. Which one am I missing? All right, what is cotangent? Yep, reciprocal of tangent, so it's got to be 12/5. Could I have done it the old way in chapter 13? Yes, I could have. I now want you to do these using the new method, exploring a new way of looking at these. So if you do it the old way, that's not okay. I want you to use your trig identities. I want you to apply these trig identities to help us find the other 5 trig functions. Does that make sense? What the objective is here? We're trying to get to the same point. We're just using another method to get there. Okay. Now, all right. Example number 2. Now we're going to simplify these trig identities. Okay? We're going to simplify them. Now, just a couple of things. You'll still be using your big 8. We'll still be using the big 8. But we also need to take a look at some of our negative angles. Okay? The negative angles. So, for example, the sine of a negative angle is negative the sine. The cosine of a negative angle is just cosine. The tangent of a negative angle is negative the tangent. Also, something we want to draw our attention to, knowing how to use this sheet, are cofunctions. The cosine of 90 minus an angle is the sine. The cosine of 90 minus 7, the cosine of 20 is going to be the same as the sine of 70. Complementary angles have the same cosine and sine. Does that make sense? So like the cosine of 60 will have the same sine as 30. The sine of 90 minus the angle is the cosine. So these two go together. The cotangent of 90 minus the angle, or pi over 2 minus the angle is the same as the tangent of the angle. Same thing, tangent of 90 minus or pi over 2 minus the angle is the cotangent. Cosecant of 90 or pi over 2 minus the angle is secant, and the reverse as well. Secant of 90 minus the angle is the cosecant. Okay? So looking at your big 8, looking at your negative angle identities, as well as your cofunctions. Those are the 3 boxes you're really going to want to focus in on. Okay, so tangent of a negative angle, cosine of a negative angle. These trig identities, the building blocks of trigonometry are sine and cosine. You got to keep that in mind as you're thinking about this. Your most basic building blocks of trigonometric functions are sine and cosine. So, as I look at tangent of a negative angle, cosine of an angle, a lot of times sine and cosine, we can't do anything to break those down any further because they're kind of the building blocks of the trig functions. So, tangent of a negative angle. What is the tangent of a negative angle? Negative tangent, absolutely. So I'm going to put negative tangent of theta times the cosine of theta. Now, what is tangent? Sine over cosine, absolutely. So this is negative sine of my angle theta over cosine of my angle theta times the cosine of my angle theta. Does anybody have a thought on what's going to happen there? Cosines cancel. I have a cosine in the numerator and a cosine in the denominator. They're going to cancel. So this simplifies down to just negative sine. Sine and cosine, if I get it down to sine and cosine, there's nothing else I can do with just sine and cosine. All right, now let's take a look at B. Taking a look at B, I have cosine of theta minus cosine of theta, sine squared of theta. All right, does anybody have a thought looking at your big 8, looking at this problem? Does anybody have a thought of anything we could try? All right, first one of number 6. Sine squared plus cosine squared is equal to 1. Okay? Now, I like your thinking there. What substitution could we make? This is all about substitution. Which one are you going to be substituting for? That's okay. That's all right. I like that you focused your attention on number 6. What made you focus your attention on number 6? Okay, absolutely. When I look at that, I see sine squared. Now, on our big 8 sheet, what do we see that sine squared is the same as? Sine squared is really 1 minus cosine squared. Does that make sense? All right, so let's try that. Okay, in place of sine squared, I'm going to put the quantity of 1 minus cosine squared. All right, now what am I going to have to do? We're going to distribute. Okay, so we have cosine of theta minus, well, cosine times 1 is cosine of theta, plus negative cosine times negative cosine squared. What is that? Negative cosine times negative cosine squared. Cosine cubed. All right. Anybody notice anything? Yeah, cosine take away a cosine cancels. So what am I left with? Cosine cubed. It's as good as it gets. Now I want to show you another way. The one frustrating thing, I will be very honest with you right now, the one frustrating thing about these verifying trig identities is there's not a right way and a wrong way. There isn't a PEMDAS. It doesn't tell you exactly the order to get this problem done in. There are a lot of ways to get to exactly the same place. So, all right, if you take that into mind, let's go back to the original problem here, and I want to show you another way to look at it. So we have cosine of theta minus cosine of theta, sine squared of theta, okay? When I look at this, I see, oh my gosh, cosine is in both of them. Is it legal then, if cosine is in both of them, to pull that cosine out in front? Is it legal to say that my GCF in those two quantities is cosine? So I could take that cosine out in front of some parentheses. I'm going to build parentheses. Usually we're getting rid of parentheses. Here I'm going to build my parentheses. Now, what is left inside of those parentheses? 1 minus sine squared. All right, now I want you to look at that big 8 sheet again. And I want you to focus in on the fact that I see 1 minus sine squared. What is 1 minus sine squared? Cosine squared. 1 minus sine squared is the same as cosine squared. So that means I have cosine times cosine squared, which is cosine cubed. Now, did it matter? Nope, they were both 3 steps. Sometimes one method will be significantly shorter or longer than another method. So we're working not only to get to the end result, but also to be as efficient as we possibly can. Does that make sense? All right, let's take a look at C. Anybody got a thought in C? Anybody have a thought in C? Looking on your big 8, looking on your cofunctions, looking at your negative angles. All right, I got cotangent squared in both of them. So I can pull that out in front. So we have cotangent squared of theta, and as I'm building those parentheses, what is left over? 1 minus cosine squared. All right, now what? What are we thinking now? Absolutely. 1 minus cosine squared is the same as sine squared. All right, so I got cotangent squared times sine squared. Now, sines are the building blocks. So I have to focus on that cotangent squared. Do I know anything about cotangent? It's cosine over sine. So what's cotangent squared going to be? Cosine squared over sine squared. If cotangent's cosine over sine, that means cotangent squared is going to be cosine squared over sine squared. Now what? My sine squareds will cancel. And we're left with cosine squared. And I know that because I'm down to a cosine squared, that's as low as it can go. Okay? All right, let's take a look at D. Let's take a look at D. Anybody got a thought in D? Oh, I need to make an adjustment. This should not be a squared. I forgot to take that off. I'm sorry. Sine of theta plus cosine theta cotangent theta. All right, now, anybody have any thoughts? When I look, is sine on my big 8? Regular old sine, is he on my big 8? No. Sine squared is, but not regular old sine. I can't do anything with him. What about cosine? Is cosine on my big 8? No. I can't do anything with him. Is cotangent on my big 8? Yeah, what is cotangent? Cosine over sine. Okay, so I have sine plus cosine times cosine over sine. All right, so if I have sine plus, well, what is cosine times cosine over sine? Yeah, I mean, cosine's like cosine over 1, right? So cosine times cosine is going to be cosine squared over 1 times sine is sine. All right, now, I'm not so sure I really like those apart. I'm not so sure that as I'm simplifying, I really want those to be apart. What process would we have to go through to combine those things? Don't fail me now, people. How do we add fractions? Find a common denominator, right? What's my common denominator going to be? Sine of theta. Sine of theta. So right now, this sine is over 1. What am I going to multiply it by to change it to sine? Sine. So I'm going to multiply the top as well as the bottom, the numerator as well as the denominator of that first fraction by sine over sine. Okay, so we got sine times sine, which is sine squared, over sine times 1 is sine, plus cosine squared over sine. Is everybody okay with that, or did I lose anybody? Are you sure? All right, now my common denominator is sine, so I can put that together. And in my numerator, I have sine squared plus cosine squared. All right, I got them together. Still looking now at my big 8, seeing if there's anything that occurs to me. This is number 1. This is like the number 1 thing you got to recognize. It's the big one. Sine squared plus cosine squared is always equal to 1. I can make all of that messiness go away. Sine squared plus cosine squared is always equal to 1. So I have 1 over sine. I have 1 over sine. Now, what is 1 over sine? Cosecant. I got it down to one thing. Happy, happy, happy. All right. Let's take a look at E. Let's take a look at E. Any thoughts on anything in E? Cotangent theta times cosine of the quantity pi over 2 minus theta. Anything draw in your attention? Okay, cotangent of theta. All right, he brings in my attention. What are you thinking about with cotangent? He is equal to cosine over sine. I can agree with that. So cosine of theta over sine of theta times, what are you thinking about with this cosine of pi over 2 minus theta? That looks a little bit funky. What? It's a cofunction. Pi over 2 is the same as what? 90. So what is the cosine of 90 minus an angle? The sine of the angle. If you see your substitutions, life gets really good really quick. And I can see some of you going, oh my gosh, really? Because what happens? Yep, sine in the numerator, sine in the denominator, and all this messiness becomes cosine of theta. And I'm down to a single cosine, so I know that that's as good as it's going to get. So far, so good? See, isn't this stuff great? Don't lie. Answer is yes. You'll love it. All right. Now, when it says simplify, I think that there's a big challenge with these problems when it says simplify, because you kind of get to the end and you don't know if you're done. Like, why is it okay to have cosine? Well, cosine is a building block for these trig functions. Cosine is broken down. You can't break cosine down into anything except adjacent over hypotenuse, and we're just not going there. Okay? Now, but when I look at something like cosine cubed, it's like, well, can I do anything with that? Nope, I can't. When I get down to some power of cosine or sine, that's as good as it's going to get. Okay? Or if I get down to a cosecant, I don't have anything squared, so I know that that's as good as I can get. But there's still an uneasiness when you get to the end of these of knowing, am I really done or am I not really done? Okay? Now, the next type we're going to do, make that easier. Okay? Definitely make that easier when we are verifying these identities. Okay? When we are verifying these identities, they tell me the answer. It's my job, algebraically, showing every single step to get there. Okay? So, for example, they are saying verify that. we know that it's true that the secant minus the cosine is equal to the sine times the tangent. That is a true statement. It is my job to show that it works. Okay? Now, couple rules of thumb. Couple rules of thumb. It typically works out best if you start working on the side that looks the messiest. It seems in math, typically, it's easier to clean things up than it is to make them messier, if that makes sense. It's easier to clean things up than make them messier. Now, just a question. If you had to look at A, which side to you looks messier? All right. Now, there's a couple reasons that I would pick the left side secant minus tangent, cosine. First of all, on the right side, we got sine and tangent. Sine and tangent are nicer to me than secant, okay? They're more comfortable. But primarily the reason I would choose the left side is because what operation is going on in between those things? Subtraction. And what's going on the right? Multiplication. 9 times out of 10, subtraction is uglier than multiplication, okay? And hopefully you will see why. Now, if I start on that left-hand side with secant minus cosine, what is the first thing that you see on that left-hand side that we can change? What is secant? 1 over cosine. Okay, so I got 1 over cosine minus the cosine. And here's the deal, and I'm picky and get over it right away. You may not change anything on the other side. It always will say sine, theta, tangent, theta. But every single step, you need to bring that down. So we just changed secant into 1 over cosine minus the cosine, but that's still equal to sine of theta, tangent of theta. Just bring the other side down. You may only work on one side. You have to choose what side you want to work on. You got to stick with that side. I may not change anything else on the other side. Okay, now I'm looking at this left side because I know that that's where I'm working. 1 over cosine minus cosine. Any thoughts? Common denominator, let's put them together. I know that these two right now are subtracted by subtraction. They're separated by subtraction. I don't want any separation. I want these two eventually to get together. So, cosine over 1, I'm going to multiply the numerator as well as the denominator by cosine. So I have 1 over cosine, subtract, cosine times cosine is going to be cosine squared over cosine. Still equal to sine tangent. All right, now, 1 over cosine minus cosine squared over cosine means that I'm going to have 1 minus cosine squared over cosine. Still equal to sine tangent. All right, any thoughts now? Beautiful. Looking at that big 8, 1 minus cosine squared is really sine squared. So we got sine squared of theta over cosine of theta. Still equal to sine theta tangent theta. Nothing changing on that right-hand side. Okay, now this is where I start to think, okay, I got to look ahead. I got to look at that right side and see where I'm headed. On that right-hand side, I would really like a sign to be out in front, correct? So I look back on my left-hand side. Do I have any signs in there? Well, yeah, I have sine squared. Is it legal for me to say, well, sine squared, that's really like sine times, well, then I'm going to leave it as sine over cosine. Sine squared is really sine times sine, so I'm just going to take one of those signs, I'm going to pull it out in front. Did I break any rules? No. Is equal to sine tangent. All right, so I got that sine out in front. That makes me pretty happy. Times, now I'm looking at sine over cosine. Sine over cosine is tangent. So I got sine times tangent is equal to sine times tangent. Once my left side matches my right side, I'm good to go. I should have no excuse to get any of these wrongs. I know what the answer is before I get started. It's my job to show all of the steps in between. Remember, you're working on one side. The other side never changes, but we continue to bring it down. Questions about that process? Are you sure? All right, let's try one more for today, and then we'll let the rest of our fun for Friday. We'll be running through the door on Friday. I'll be so excited. All right. I know. I totally can understand that. Sine theta times the quantity of tangent of theta plus cotangent of theta is equal to secant of theta. Now, I can only work on one side. I made the statement that 99% of the time, it's easier to take ugly things and make them pretty. Okay? Which side is uglier? The left. Absolutely. Secant of theta is equal to all that junk. There is no question my left-hand side is way uglier than my right-hand side. All right. Does anybody have a thought on what we want to do? All right. What's tangent of theta? Sine over cosine. Okay, so I got sine times the quantity of sine over cosine plus, what about cotangent? He seems kind of ugly too. Cosine over sine. Equal to, don't forget to bring it down, secant of theta. All right, looking good. Any thoughts now? Where?
In parentheses.
Do I have sine squared plus cosine squared? Then I don't have a 1. Does that make sense? It's the only time I have a 1 if I see a sine squared plus cosine squared. What are we thinking? Eventually, folks, I got to get down to one thing, right? Which means eventually I got to start putting these things together, right? The only way I can get down to one thing is if I have things that are together, right? Right now I have two quantities. That's not very good. So what am I going to do to take those two quantities and put them together? Okay, I got two options. I could either distribute or find a common denominator and put these together. Which one do you prefer? Common denominator and put them together? It doesn't make a difference. There is no right way, no wrong way. You can do it either way and you'll be perfectly fine. If we find a common denominator, put them together, my denominator is going to be cosine sine. So that means I'm going to multiply this one by sine over sine, and my second fraction I'm going to multiply by cosine over cosine. Is everybody okay with that? In my denominator of that fraction, I'm going to have cosine sine, and in my numerator of that fraction, I'm going to have sine times sine, which is sine squared, plus cosine times cosine, which is cosine squared, and that fraction is still being multiplied by that sine of theta out in front. And bringing it down, equal to secant of theta on the right-hand side. Didn't change him for anything. All right. Anything we notice now? Sine squared plus cosine squared. When I see that piece, when I see sine squared plus cosine squared, that is time for celebration, because we automatically know that that is a 1. So I have 1 over cosine times sine, and that sine is still out in front, equal to, bringing that right-hand side down, it's secant. I keep writing it down every time. I never change it. All right, now what? What? Distribute. Okay, well, I don't even really have to distribute. I just have to multiply, right? This is sine over 1, right? So sine times 1 is going to be sine over 1 times cosine sine is just going to be cosine sine. Equals, bring that right-hand side down, never touching it. Secant. All right, now what? Sines cancel, which means what do I have on that left side? 1 over cosine is equal to secant. What is 1 over cosine? Secant. Secant equals secant. And Everybody's happy.
Are we ever going to get ones that are like no solution? Like,
Nope, nope. I'm telling you they work. When they start, they work. All right, should we do C? We have a little bit of time.
Okay.
Oh yeah, let's do C. It's a
Okay.
fun one. Yeah, we'll get a head start. We'll get C done today. All right, looking a little bit different in C. This is a great one. Cosine secant over 1 plus tangent squared equals cosine squared. All right, which side you working on?
The left.
The left is uglier than the right. No doubt about it. Okay, so let's take a look over there on the left. You got cosine secant over 1 plus tangent squared. Any thoughts?
1 plus tangent squared is
Nice catch. Nice catch. Beautiful work. 1 plus tangent squared is on my big 8. 1 plus tangent squared is secant squared. So we have cosine secant over secant squared equals, bring down that right-hand side, never touch it, never change it, just rewriting cosine squared. All right, now what? Now what? All right. I have a secant on the bottom. I have 2 of them on the bottom. Excuse me. I have a secant in the numerator. I have 2 of them in the denominator. So the one in my numerator cancels with 1 of them in the denominator. So I have cosine over secant equals, bring the right-hand side down, never touching it, cosine squared. Now what? Obviously this cosine, I'm not touching him because I know I'm trying to get towards cosine squared. I know I'm not touching that cosine. So what am I going to touch? What is secant? 1 over cosine. So this is like cosine over 1 over cosine equals, bringing it down, cosine squared. Every time, every line. What do I do when I divide by a fraction? Multiply by the reciprocal. So that's really cosine times cosine over 1 equals cosine squared. Well, what is cosine times cosine over 1? Cosine squared. No question, cosine squared equals cosine squared. That's perfect. Questions with that? Good stuff. Love this stuff. All right.